All right, let's take a look at this big one here, this scary looking one. Number 3. Predict whether each of the following reactions will occur. For each reaction that will occur, that means that probably at least one won't. Identify the reaction type and complete the chemical equation by writing its products formed and balancing, right? Products formed and balancing the final equation. So we're needing to do several things for each of these instances. Now, we need to refer to table A12 on page 900 of your textbook for a solubility chart. That's so that if you know something is going to stay solid or be in the aqueous phase. Okay, so I'll just show you how to read that table as we go. So first up, this is a proposed double replacement. So here's an AX and a BY. Okay, so we're proposing that both everyone involved changes partners. So this would be double displacement. And let's see here. So if we were to complete the chemical equation by writing the products formed, this would end up being barium phosphate, right? Sorry, I got confused. I'm giving myself some extra room here because I don't know what that subscript needs to be. And I don't know what phase it is. I'll look that up on the chart in a second. And what's left? Sodium nitrate. Again, I don't know what phase that's going to be, so I'm just going to leave some space for that. Now, first thing I'm going to do is I'm going to go to this right here. Barium is listed above sodium, right? So there will be some displacement reaction going on here. But if you flip all the way to page 900 in your textbook, you'll see this A12 solubility chart. This is going to tell us what state of phase these things are going to be in. So I don't know what this is per se. When barium bonds with phosphate, what phase is it going to be? So let's take a look. Here's barium, and on the top here, here's are the anions. What I'm going to do is I'm going to slide over until I find in the barium row until I find phosphate. I see A for barium phosphate. What does that mean? A means soluble in acids, insoluble in water. So it could be soluble if it's in an acid. Is this an acid? No. No acid. No dissociation of hydrogens possible. So that means that this is insoluble because it's in water. It's an AQ. It's dissolved in water. And so this is not going to be soluble. Means it precipitates out and creates a solid. Now let's do the same thing for sodium nitrate. Where is sodium? Sodium. Let's go all the way over for nitrate. Sodium nitrate. What does D mean? D means, oh my gosh, it decomposes in water. Holy cow. It means these are definitely going to split apart. Definitely going to split apart and be in the aqueous phase. Oh, yeah. Definitely going to split apart and be in the aqueous phase. So we got a solid product and an aqueous phase product. But we have to balance these charges, right? That's important because these are ionic. These are ionic. We have to balance the charges. So in order to balance the charge of a barium and a phosphate, you need Ba3, phosphate 2. And then, let's see. Oh, yeah. Sodium is just a +1, and nitrate is also a -1. So that's just a 1-to-1 ratio. But now that we've predicted the products, right, we know what the little subscripts are. Now we need to balance the final equation. So this needs to have a 3. Oh my gosh, I wrote those down in the wrong spot. A 3, a 2. My goodness, forgive me, please. I'm messing this up. This is a 1. Believe me, that's a 1. And this is a 6. All right, moving on to B. Al plus O2. This can be either synthesis or combustion because we are putting this together with oxygen. Okay, but more often than not, they'll be asking you this to show that you know that this is a synthesis, two simple things coming together to form a more complex thing. What would the potential products be? Well, it probably forms some sort of aluminum oxide, but we need to balance it because this is definitely ionic. To balance the charges of the +3 aluminum and the -2 oxide, we would need to go to -3 there. Last thing we're going to have to do, we have to balance the final equation. In order to balance this, we would need 4, 3, and a 2. Moving on to C, solid iodine reacting with sodium bromide. Now, pay attention. Iodine is a halogen. Remember, like displaces like. So when we go over to our tables, switch to my activity series, right? This is the one that's in your book. Iodine is over here in the activity of halogen nonmetals. Nonmetals displace nonmetals. So when you look at this problem, we're not seeing if iodine can displace sodium. We're seeing if iodine can displace bromine, right? Like displaces like. Nonmetal displacing nonmetal. So is iodine listed above bromine? No, it is not. No, it is not. That means that there will be no reaction. And I'm off scot-free. Moving on to D. Looking at this, I can definitely tell that that's a combustion. And because it is a combustion, my products are going to be CO2 and water right off the bat. Now all that's left to do is balance, right? That's one of the easy things about combustion. I know the products are going to be CO2 and H2O. All that's left to do is balance. So I have a 1 right there. I have a 4 right there. Let's see, and then I would need a 3 and a 2. Lastly, let's move on to part E. Part E, the electrolysis of molten potassium chloride. So we're splitting this up. We're trying to make this split apart. And so we would have potassium chloride. It's molten, so it's liquid, decomposing into solid potassium and chloride. Now, chlorine. Now remember, chlorine is a diatomic molecule. It's going to be Cl2. So electrolysis is a kind of decomposition, so it's definitely decomp. And all that's left to do at the end is balance. I need a 2 in front of the start, 2 in front of the potassium, just a 1 in front of that chlorine. One thing I forgot to do, I'll just do it now, is the states of phase right up here. Aluminum oxide, what phase is that going to be in? When I move to page 900, looking for aluminum oxide. Aluminum oxide is an A, soluble in acids, non-soluble in water. Okay, so we're not in an acid, we're just in water, so that means that this would be a solid. Okay, that would be a solid. And then we know that this is going to be a gas, and this is going to be a liquid, just from memorization site.